we'll look at the basics of variables and how we create them. We'll look at some of the different types of variables Go supports, and then we'll do a bit of a sidestep showing the common short assignment method. Now that's buzzwords at the moment, but you'll get it when we get there. After that though, we'll look at pointer variables, and we'll see how they let us pass variables by either value or reference. And of course, again, that's more buzzwords, but we'll demystify everything as we go. Anyway, look, we'll round things out with a look at constants, then how we can access environment variables on your system, and of course, we'll do a quick recap. Now, look, to help with the demos, we'll use a simple program that shows info on a Pluralsight subscriber. So maybe their name, which course they're watching, and whereabouts in that course they're up to. I don't know, like maybe Module 4 Clip 2 or something. But the thing is, right, it's just a daft oversimplified program whose only purpose in life is to introduce you to variables. So it is not supposed to be production grade code. Anyway, look, we know by now that talk is cheap, so let's get coding. Okay, we already said that Go's a statically typed language. And we said that's jargon for, well, you know what? It means a few things, actually. But for now, it means when we declare a variable, we've got to tell Go what type it is. Like, is it a text string or, I don't know, maybe a floating point number or something? Anyway, look, we've got the framework of a program here. It's actually in the variables folder of the course's GitHub repo, and I think it's called var-framework.go. Maybe if you want to clone it locally and work from that. And if you do, the commands are here and you'll need git installed to be able to do that. But you know what? You don't have to do that, so maybe feel free to just type the code into your editor. Or you know what? Even copy and paste it from the file on GitHub. It's all good as long as you've got that code in your editor. Well, if we declare variables up here at the package level, so outside of any function, we've got to do it with the var keyword. So no, Go doesn't let you use non-declaration statements at the package level. Okay, well, for now we go var, and then I like to list them out on their own lines like this. So each line here is starting with the name of the variable and then the type. Now, on the topic of names actually, and I'm not sure if I said this already, maybe I did, maybe I didn't, but variable names have got to start with a letter and they can't be any of the 25 Go keywords that were shown here on the screen. So, I mean, you can't call a variable var or func or to be honest, any of these 25 words on the screen. As well as that though, they can't contain spaces and no special characters like math operators and the likes. Oh, do you know what? And of course, look, do yourself and the universe a favor and use common sense. Like, for the love of all things good, give variables meaningful names and preferably short names. And as well, you know what? If the variable name is long and it contains more than one word, then capitalize the first letter of each word just to make things more readable. Camel case, yeah? Right, do you know what? And on the topic of this, for now, right, always make the first letter of a variable lowercase. Because, and I don't really want to get here now, but we'll find out later in the course that making the first letter of a variable a capital letter, that makes that variable visible outside of the package it's defined in. But you know what? That's a bit advanced for now. We'll get to it later. Well, look, it is possible to list variables of the same type on the same line like this. So name and course are strings, and then module and clip are integers. And then actually declaring variables like this where we're not assigning them any values, they'll be initialized with 0 values. So the integers will get actual zeros, yeah? And then the strings will be assigned an empty string. In fact, do you know what? Let's add some code to our main function here to see if that's actually true. Now, before we run this, right, these are just a couple of println functions like we've already seen. Only this time, within the parentheses, but outside of the double quotes, we're referencing the variables we created. Well, if you're in VS Code, you can hit Run Without Debugging up here and it'll show you the results at the bottom of your screen. And you know what? Feel free to do this with all of the examples if you're using VS Code. But if you're using something different, just open a terminal in the directory where you created and saved the file, and you will need to save the file. But then just do a go run like this. I've called mine vars.go, yours might be different. But look, that's our program. And actually, yeah, it's not so easy to tell with the strings because they're just empty spaces, yeah? But the ints are clearly initialized as zeros. So, 4 variables, each assigned a name and of course a location in memory, but importantly, initialized with 0 values. Oh, and each one's got a type. And actually, speaking of types, that's where we're going next. So we can check the types of variables and stuff in Go through something called runtime reflection using the reflect package. So let's go and import that up here. And then let's add these 2 statements down here. Now, again, they're just println functions, only this time we're calling the type of function from the reflect package as well. So this one here is going to print the type of the name variable, and then this one, the type of module. Well, tell you what, save that and we'll give it a run. Okay, name is of type string and module is of type int. But yeah, I mean, we knew that, right? We called it out when we declared them. Well, Go actually supports something called type inference, and it's pretty cool because it lets us write shorter code. So if we change the variable declarations up here to be this, see how we're no longer declaring the types, but we are assigning values. Well, Go is clever enough to figure out that Nigel Poulton and getting started with Kubernetes are both strings, and then that 4 and 2 are integers. Although, you know what, I'm saying it's clever enough. Let's save that and run it to see if it actually is. Magic. Take a second to look at that. Okay, now look, I'm not a fan of initializing multiple variables on the same line. I just think it's easier to read if we list them out on their own lines like this. Now then, a couple of things. These double slashes here are how we add line comments in Go. Basically, anything we put after them are comments and get ignored by the compiler. But the thing is, they're really important for good code, especially if you work in a team where, of course, it's important for your teammates to understand the code that you've written. Well, as well though, Go is really picky about types. Like, you can't add or subtract a string from an integer. And that's a bit of a daft example. I mean, how would you do that, right? It makes sense that you couldn't. But you can't even mix and match integers and floating point variables when you're doing math operations. Well, look, to show this, I'm going to change the variable declaration here so that module is actually a string. Now, I know it looks like an integer, but because I'm putting it inside of double quotes, I'm telling Go, no, store it as a string. And you'll see why in a second. Well, this code here will try and sum that module variable with the clip variable. Let's give it a try. Okay, no joy. And that's expected, right? Even though module looks like an integer, it's a string, which is where conversion comes to the rescue. So, the struct_conv package has a bunch of functions that do type conversion, and we know the crack by now, right? We import the package up here. We'll add this code here, which, yeah, okay, it might look a bit complex if you're new to this, but believe me, it's not. And you know what? It's a good way to get you thinking about some of the stuff that we're going to cover in more detail later. Well, the main part of the code is here. Now, yeah. Okay. We've imported the struct_conv package, and we're using this A to I function that converts ASCII strings to integers. So, we're feeding it our module string, and it'll return the equivalent integer. Only it gives a return code as well, and we have to do something with that return code. So, we're saying this new I module variable here, assign that the integer that the A to I function is going to return. And then this air variable, assign that the return code that the a to I function will return? Well, then we're doing some basic error checking and saying, so long as the return code's a 0, which indicates a success, yeah? Well, as long as we get a success, do this calc here and print the answer. And yeah, if it seems a lot, don't stress. The point is, we're using a function from an external package to perform a type conversion. But as well, we're just handling it with some good old-fashioned error checking. And we'll see a bunch more of this as we crack on, so it will all fall into place as we go through the course. Well, I guess we should save that and check if it works. Which it does. So the a to I function from the struconv package converted the ASCII string 4 to the integer 4. Then, after that, the calculation worked because obviously we can sum two integers. Whew, marvellous. Well, I've dropped this little gem in here, so I should probably explain it. Okay, quickly back to variable declaration. So far we've only talked about variable declaration outside of functions at the package level. And you know what? Declaring them here makes them available to all functions in the entire package, so global in scope. But if we declare them within a function, which will do a lot, we can use a shorthand, more concise method of declaration like we did here. Now, declaring variables within a function makes them local, so only available inside the function they're declared in. But that's okay for us, because right now we've only got one function. Anyway, if we declare them here like this, then we can get rid of these up here. Now, this might seem a small thing, declaring them like this, but it's the most common way, and you'll see it everywhere. In fact, if we jump over to the Kubernetes project on GitHub here, Kubernetes is written in Go, yeah? Well, in this package, if we search for the var keyword, so the long way of declaring, niente, not a single occurrence. But if we look for the short assignment statement, there's loads. So this is the really common method. But back here, like we just said, it only works inside of functions. Oh, and obviously, if you're not in a position to be assigning values to your variables yet, you'll have to use the long form with the var keyword. Well, I tell you what, let's throw in another variable to indicate whether the viewer has completed the course. So this one is a true or false Boolean, and we're assigning it false for now. Well, let's save that and try to run it, the emphasis being on try. Okay, check that out. No joy. Go's not liking the fact that we've created the course complete variable, but then not used it. I guess it doesn't like waste. Only there's a but or a caveat. You can totally declare a variable at the package level up here and then never use it. But if you're declaring it inside of a function, sorry guys, you gotta use it. Well, I'll tell you what, for now we'll comment that out and try it again. Okay, it works this time. So we've switched our variable declarations to inside the function and we've adopted the short assignment method. Next up, we'll learn about pointer variables. Right, come on, let's start with some jargon. Go passes arguments by value, not by reference. And what, pray tell, does that mean, Nigel? Well, on this line here, we're passing the module variable to the a to I function from the struconv package. Only we're not. What actually happens behind the scenes is that Go makes a copy of module and passes the copy to the function. So real quick, when we create a variable, Go allocates it an area in memory. And let's say the address of that memory is hex AA and it's the course variable with the value getting started with Kubernetes. Well, when passing this as an argument to a function, Go makes a copy of it and passes the copy to the function. See how it's got a different address but the same value? Well, this means we've got two copies, and I suppose we could say it is a form of immutability, like any changes made by the function only affect the copy at hex BB. But this is only the default behavior and we can absolutely change it. Well, no, actually, I should say we can get around it, and we do that with pointers. So, as an example, if we add this line here to our code, by putting the ampersand here in front of the course variable, when we run the code, we'll see the memory address of the variable instead of its value. So we'll give that a save and let's try it. Alright, there we go. Hex whatever, yeah? That's the memory address of the variable. Anyway, pointers, as the name suggests, are special variables that point to other variables. You know what? It's probably easiest if I just show you. So we've got an existing variable called course, and we know that it is storing the value getting started with Kubernetes. It's a great course, by the way, and you should most definitely take it. Anyway, this line here creates a new variable called PTR, and then the asterisks before the type makes it a pointer variable. Then the ampersand course bit on the end says point it to the memory address of the course variable. So if we add this line here, obviously it's printing text and variables to the screen, but you know what? Let's step through it. We are printing this text here that says pointing to course variable at memory address, and then of course we want it to print the memory address. So we do that by printing the contents of the PTR variable, which, remember, because it's a pointer variable, is the hex address of the course variable. Stick with me. We're also then saying which holds the value, and then we're wanting to print the value of the variable. So we do that by referencing the PTR variable again, only this time we actually dereference it with the asterisks. So this time it'll print the value stored in course, which should be getting started with Kubernetes. Oh, tell you what, let's give it a try. Oh, and remember to save your changes first. Alright, magic, that looks good. However, I totally get it that it can be confusing, especially if it's new. So, for the sake of those who are confused, and it's totally alright to be confused, most people are when they're first learning pointers, but winding it back, variables are addresses in memory that store data. Usually we store a useful value, but pointer variables store the memory address of other variables, so they're useful for referencing other variables. Well as that, in code, the asterisks performs two functions. First up, if we declare a variable with an asterisk, like we did here, then that asterisk makes it a pointer variable. But when referencing pointers in code, slapping an asterisk in front of it dereferences it, which is jargon talk for instead of telling us the memory address of the variable you're pointing to, actually tell us the value inside the variable you're pointing to. Whew. So this gives this, and this gives this. Well, finally, putting an ampersand in front of any variable will return that variable's memory address. And you know what? We'll see it really soon, but pointers are really important when we start using functions. And actually, you know what? Let's quickly set the scene for that. Right then, I think this code's getting a bit cluttered, so just a quick bit of tidying up. We're done with the reflect and strconv packages, so we'll lose them. We are going to use the name and the course variables, but you know what? We'll lose the rest, because remember, Go doesn't like it when we create a variable inside of a function at least, and we don't then use it. And you know what? We'll just lose all of this here. So basically, we're at the bare bones of an app. So what we're going to do here is write a simple function to change the value of the course variable. And we'll get properly into functions in the next module, so don't overthink things right now. We're just looking at how variables get passed around. Anyway, in our main function here, let's print out the current value of course. And look, I'm just adding the line feed character on the end here to make the output on the screen easier to read. Well, next let's call to a new function called update course, and we'll pass it the course variable. Now then, we've just done this. Go doesn't actually pass the course variable, yeah? It makes a copy and it passes that. And this is crucial, so keep that front and center of your thinking. Well, now to write the function. So in the function signature here, and that's just this top line that we're writing, we give it an input, that's the course variable or copy, yeah? And we tell it the type, which is a string. And then every function returns an output, which for us, that'll be an unnamed string. Basically, we're putting a string in and we're getting a string out. But remember, don't overthink this yet. We'll come properly to functions next. Let's add some statements to do some work. So this line here is assigning a new value to course. This line's printing that to the screen, then we're telling it to return the updated value. And that's our function. Take some input, change it and print it to the screen, and return a value. So I'll tell you what, back up here we'll add another println to check whether or not the change we made in the function actually stuck. Now, a couple of things. First up, program flow is like this. We start at package main, import a bunch of other packages, and jump into func main. Remember from right at the beginning, package main and func main are the program's entry point, so they're always the first things to run. Next, we initialize a couple of variables and print them to the screen. And it's all pretty orderly so far, basically starting at the top and stepping through line after line. However, this call here to the function switches flow to the function down here. We then step through that one line at a time, and when it's done, flow returns back to here and we run this line before the program exits. Cool. Well, the other thing I wanted to mention is this line here. Notice how we're just using the equals operator and not the full short assignment. That's because we're not initializing a new variable, we're assigning a new value to an existing one. Well, let's see if it runs. Okay, so current course is getting started with Kubernetes. We're changing it to getting started with Docker, but then it's back to getting started with Kubernetes. But that's expected, right? The update course function made changes to a copy of the course variable, not the original. In fact, the original was unchanged, and we can see that here. Okay, fair enough. But what if we actually want to change the original or the actual variable? I tell you what, no sweat, we're going to do that next. Okay, to get this update course function to change the actual value of the course variable, so instead of a copy, we need a pointer, which, if you remember from before, is going to be a combo of ampersands and asterisks. So we're initializing course here and we're assigning it the value getting started with Kubernetes. Then we're printing it to standard out. But then, as things stand, this call to update course is creating a copy and working off of that. Well, if we lash an ampersand on the front here, instead of sticking a copy of the value getting started with Kubernetes onto the stack, it'll stick a pointer or a reference to its location in memory. Well, then down here in the function, we stick an asterisk here before the string. Remember, doing that makes the variable a pointer. Then we need to stick an asterisk here when we're changing it to getting started with Docker. So what this is doing is telling Go to assign getting started with Docker, which is another epic course by the way, but assign this new value to the location in memory that the course pointer variable is referencing. Oh, yeah, another one here. If we don't, we'll get the hex memory address again. And another one down here on the return. And then I reckon that should work. So this time around, we should actually change the original value. Well, moment of truth, I guess. Like we ever doubted it. So, current course is getting started with Kubernetes. We're updating it to getting started with Docker, and the change has stuck. You know what? That, folks, is pointers and passing by reference, which can be very useful. Well, next on the cards, constants. So this will be nice and short because constants are pretty much the same as variables, except I guess for the obvious. Constants are immutable, so they never change, whereas variables, well, these most definitely can and do change. Anyway, I'm cleaning this up so that we've got pretty much a new program, and I'm going to save it as consts.go. Now then, if your package imports and things go away like mine just did there, it's probably because you're using VS Code with the Go plugins and you've imported a package that you're not actually using in your code yet. Well, we actually are going to use thumped, so I'll put it back. Okay, well, constants are declared in Go with the const keyword, and it's pretty much the same as the long-form variable definitions that we saw earlier. Though, actually, this is the only way to declare a constant, so there's no shorthand way like we have inside of functions for variables. Well, anyway, look, this one is defining probably the world's most famous constant, the speed of light, which, if you didn't know, travels at pretty much 186,000 miles per second. Or, I guess, 300,000 kilometers a second if you prefer kilometers. Kilometers? Kilometers? I don't know. Well, look, this will print it to the screen, and I think we'll give that a save and a run. And we're good. Simple stuff, yeah? Now, look, really quick, just to prove that constants cannot be mutated, this line is trying to change it. So speed it up a tad, yeah? Actually, to warp 9 in miles per hour. And I know I'm mixing miles per hour and miles per second, but you know what? Who cares? But I tell you what, let's try it. Nah, no joy. As we said before, constants can't be changed. Okay, well, you know what? Time for a quick look at how we interact with environment variables on your system before we wrap the module with a recap. Right, a super quick look at environment variables with Go. Now, first up, we're in a new program file here. And, well, environment variables are, well, they're variables, yeah. Or they're settings on your host system. So, for me right now, that's my Office Mac, because that's where I'm running the demos from. For you, it'll be whatever machine you're following along on. And it's pretty much the same whether it's Linux, Windows, or Mac. Now, to get access to environment variables, we're going to leverage functions from the OS package. Actually, it gives access to a ton of OS stuff, so not just environment variables. But we know the deal by now, it gets imported up here. Anyway, the environment function here lists all our environment variables on our system. So, let's save that and see. Now, this time the file's called env.go. Okay, well, yeah, it's a proper mess, but it is a list of all of the environment variables on your system as key value pairs. But you know what, I tell you what, a simple loop here like this that'll iterate through them and then put each one on its own line. And look, we'll get into loops later, so don't worry about it. It's just going to go through that list of environment variables, whack each one on its own line. So we'll give that a save and go again. Oh, miles better. But I tell you what, let's jump back to the variables program that we've been working on. Mine was saved as vars.go, but there is a fresh copy in the variables folder on the GitHub repo called envvars.go, and you can work from that if you didn't save it from earlier. Anyway, look, first things first, we've got to import the OS package. Then down here, let's change the name variable so that instead of assigning it this string literal here, where it's my name with a capital letter at the beginning of each of my, I guess, first name and last name, instead of that, let's assign it the value of the currently logged on user. Well, to do that, it'll be os.getEnv. Oh, actually, before we do that, see all of the options that we've got here. So env page size, PID, a bunch of host system stuff, yeah? Well, we want get env, and then because I'm on a Mac, I want user. On Windows, it's username. But do you know what? It's all simple stuff. It's just an environment variable on your system holding the name of the currently logged on user. Oh, and of course, we're assigning the output to the name variable here. Well, I'll tell you what, give that a save. And then in the terminal here, well, you know what? First up, I'm going to show you the value of the user environment variable. Okay, Nigel Poulton with no capitals or spaces. Well, let's see if the program pulls that. And it did. Nigel Poulton like that instead of with capitals and a space because it grabbed the value from the environment. Spot on. Well, of course, we're only just getting our feet wet. Totally feel free to have yourself a play around with some of the other stuff available through the OS package. But do you know what? As far as this set of lessons on variables goes, we're done and it's time for a quick recap. Okay, I feel like we covered an absolute ton, so I'll keep this as sharp as I can. We learned that we can declare variables with the var keyword, and we can even do that without initializing them with a value. But if we do that, Go automatically assigns them a default value. We saw that strings default to an empty string, integers to a 0, and I think we saw that booleans get a false. Well, we said that variables declared at the package level are global in scope, so available to all functions. And also though, when declaring at the package level, so outside of any function, the only way to do it is with the var keyword. However, if we're inside of a function, then the more idiomatic way is with the short form operator. And to be fair, that's the way we'll do it most of the time. We also saw that Go supports type inference. So if we do initialize a variable with a value, well, Go's clever enough to figure out what type it should be. We also said that Go passes variables to functions by value and not by reference. So instead of passing the actual variable itself, Go creates a copy with the exact same value as the original, and it passes the copy to the function. But do you know what? That's not always what we want, so we looked at pointer variables. And these are how we can force a function to work on the original variable instead of a copy, and we call that passing by reference this time rather than by value. Then we switch to constants, which honestly are pretty much the immutable sibling of variables. They look, smell, and feel a lot like variables, only once you create a constant, you can't change it. Well, then we wrap the module looking at how Go can access environment variables from a host system and use those values in programs. And that was about it, though of course we've only covered the basics, and you should feel free to take some time to play around, make a bunch of mistakes, and generally try things out. Well, next on the card, and this is a good one, functions.